Welcome to our presentation. My name is Mohammed Islam. My colleague Wei Han will join with me in the later phase of the presentation. This is our quick introduction, and this is the easiest slide for us to explain because we don't need to say anything. I will skip it. Before going for the deep dive of our technical details, I would like to set up the stage or the context of our presentation. More importantly, I will explain what we will talk today and what we will not talk today. You know, at Uber, most of our data ultimately land into Hadoop. So we will talk about Hadoop security, how we make Hadoop secure. Someone may call that Hadoop security is not new. It is nearly 8 to 10 years old. Actually, I did in my previous assignment 8 years back at Yahoo, the Hadoop security things, I was part of that. So what is the new thing there? That is our focus of our presentation. How we take existing open source technologies and merge it with our internal services or technologies to achieve our goal. Bear with me, I am just learning how to go forward, go backward, okay. Yeah, so one thing we'll not cover, that is Hadoop security is a big topic. There are multiple ways people can secure the same data. And we are not going to talk all of them in this presentation. We'll primarily talk one approach, and that is fully related to Hadoop. And regular disclaimer is also applied here. Let's start with some common terminology that we will use in our presentation in our later slides. So what is data security? I don't want to read the sentence there. It's very obvious. However, how we convert this one-liner requirement into a technical implementation. We address this issue in 4 A's: authentications, authorizations, auditing, and anonymizations. We'll talk about these 4 pillars of security in our next slides many times. First, let's try to talk about them in very briefly. Authentications means verifying the user identity. Authorization means validate the access control. So these 2 terminology is very common to a lot of us, but few of us become very much confused with this seemingly similar word. So for them, the easiest way to remember is authentication means who you are, and authorization means what you can do or what you cannot do. Number 3 is auditing. This is a 3rd pillar of data security, which is sometimes I would say overlooked from the engineering community, but secure community is very much on top of auditing. The auditing means all of our access control, all of our access should be tracked in some place. Very basic stuff. How this can be used in the security is post-mortem. That means for any region, there is any security compromise happen, there's 2 questions arise to find out how big is the security compromise happen, what is the extent of that, how many data sets, how many records is being compromised. Secondly, it comes, right, how this security hole being opened up, what is the place, that is for future purpose. So all this information auditing is the main place to start with. Second is anomaly detection. This is more of engineering problem, machine learning, AI. That means by looking into the audit log, if you can sense some anomaly, some abnormal usage pattern come out, you can create the alert. Take an example. At 3 a.m., you find out somebody from across the Atlantic is accessing to your data sets that they never access. Definitely, audit log can track this thing and create some alert to address this anomaly. Next one is anonymizations. It is an overloaded term. People are using this term synonymously for different terminology. It could be tokenization, masking, one-way hashing, a lot of different terminologies are there. I'm not going to talk about that things here, but one thing I'm to just bring it to you. This anonymization has a different challenge. How much anonymization is good? There are two competitive requirements. One is security people tell, anonymize everything, mask everything. On the other hand, the business people tell, give me some information. I don't need everything, but I need something so that I can serve the user better. So these are sometimes competitive. It depends on different situation, how to address this thing. So for example, this picture, I took it from online and as an anonymization picture. But security people may come and say, oh man, is it sufficiently secure? Because I can guess the gender of the person. If I push myself a little further, I can get something else, some other feature of the personality. This may make our business people happy because you cannot guess anything. So that is actually the dilemma in this anonymization world. Now let's look into our make our hand dirty in the implementations on the design. When we start our security things long time back, we put some of our goal. That is, we need to secure all access path to HDFS. It's not only like Hive or Spark or XYZ, every path. That is our goal. Then the second goal is also somehow related to the first one. That is enforcement at the lowest level. By lowest level, I mean, you know, Hadoop has a multiple stack, HDFS, Hive, XYZ, a lot of stacks are there. We want to capture the security or enforce the security as lowest as possible. The reason is we want to maximum surface area cover. That means actually most of the access can be covered in the lowest level because everybody have to come to this funnel. Second is also like every company has their identity management system, like Active Directory or similar type of things. We do not want to build a separate Active Directory management or separate identity management for Hadoop. We want to reuse the same thing. In the same theme, for policy also, like data access policy, we want to reuse the same thing. For example, same data can move from different data store to another data store. Hadoop is happen to be one store, maybe very important, but there are other stores are there. They also store the same data. So we should not isolate ourselves by putting, okay, our policy is only Hadoop policy, because it will be hard for the company to enforce this consistent policy for every store. So that is our goal. Having said that all of these technical requirement, a security requirement, we have to make sure one thing. There is no collateral damages. By collateral damages, I mean, you can design the security architecture in such a way that will restrict your developers' productivity. Take an example of, in Hadoop it is more important because Hadoop, by default, it is an open data platform. Every other month, there are new products are coming in the open source. Your engineer want to use one of the such product, and they want to bring it to your Hadoop ecosystem. But you tell, no, hold on. My security infrastructure, this requirement is 10. You need another 6 months of development cycle only to come to our security infrastructure. That will be very much counterproductive. And we need to be careful about that. Let's go a little bit details word. Based on these design considerations, as you can see, HDFS is our source of the truth of all the data. We put heavy duty fortified this HDFS with a lot of bell and whistle there. I will tell actually how we did. And then we have a lot of other stacks, very common things. Our compute engine and other things are there. On top of it, generally, every company has some tools and BI tools and other things to make it easier for their user. There the end user come to the first. So in this picture, if you see that how this security things is being done, at the very beginning, this user will come, their identity will be challenged in the outer layer. That means they will be give you login, password, something. So their identity will be confirmed. After that, all the middle layers will just pass the username or securely to the lowest level. When it will land to HDFS, that guy will then do the ultimate enforcement. So that's the same thing actually I wrote in this outer layer and inner layer, how they communicate. Let's go to our first authentication things here. That is our first pillar. And this is we have an architecture for that one. If you see, this is nothing big new thing here. Most of the company are using, nearly 80% of this architecture is being copied from most of the people. However, if you see higher level, I will tell that 20% thing that probably our internal things that we did. I will try to mention few of them. There are basically 3 different ways the user can connect to Hadoop ecosystems. The first way is the engineer who know how to write the code and other things. They go to their gateway machine, we call it, do the kinit, and at that time they will come and do their authentication is being done here. They pass the Kerberized ticket to the Hadoop ecosystem. The second one is coming on the batch route. By batch we mean like Apache, Uzi, Apache Airflow, Azkaban, those type of scheduler. We have our own internal scheduler there. And we build it ourselves in-house. In that case, user also come through the front-end side. They do their authentication. But after that, that same job is being submitted every day forever. This scheduler is actually taking care of all the security of the user identity. In this case, we use Kerberized and Delegation token for this purpose. Third route is a different route that most of the time interactive query and other things come. To do that, I want to take a pause on this flow of my discussion. I want to tell some bigger picture of any company. You know, Hadoop always support Kerberized. But outside world, there's a bigger world there, non-Hadoop world is there in any company. They not necessarily use Kerberized, and rightly so. If somebody deal with Kerberized, they know the complexity of the Kerberized. It's not that easy. So for any reason, there might have some custom token or custom authentication mechanism there. So there is 2 worlds. Custom, that maybe every company has their own, and Hadoop is telling, I need to be only Kerberized. So to make these 2 worlds working, we were extensively using Apache Knox. I will talk about this route in the next slide. So basically what we got here, 2 things, mainly takeaway from this slide, is I just already I mentioned it again, Kerberized, Delegation token, Hadoop, outside world, something else. We need to solve this problem. So in this case, actually, we use Knox, thanks to the Knox community, to solve this problem in an easier way for us. And we actually use Knox for seamlessly translating this custom token to the Kerberized world seamlessly. And we do some, next of the slides are actually kind of a bragging that we worked on the Apache community, just to say some of the Jiras are there, actually we worked on the community. So we are open source actually, basically. So next item is more of a impersonation. This is another common use case that happened at Hadoop world. Impersonation means like the same example I mentioned a few minutes back, that is the people comes to submit the job to the scheduler like Uzi, they are being authenticated at time 0. The rest of the time or the rest of the year, the person is not there. In that case, that intermediate service, Apache, Uzi, or Airflow, they need to do the impersonation. That is Hadoop concepts. But same thing may not be readily available in our internal authentication system. Again, we rely on Apache Knox. We borrow the idea from Hadoop, and we basically put a white list of the services who can do this impersonation and do the rest of the translation in the Apache Knox layer 2. This is my last concept about authentications. It is the delegation token. So delegation token, again, is a Hadoop concept. It is being used for name node, Hive, and HBase extensively. That is the authentication mechanism internally these services are using often. On the other hand, we actually did it off-level. That means we use it some other cases. There is 2 high-level use cases. Number one is, take the example, Presto. Presto does not have any delegation token concept. We had 2 choices. One is we can build this delegation token support in Presto. That will take at least 6 months, plus minus of stabilization of the feature. This is number one option. Option 2 was somehow hack this delegation token and reuse the same thing. So we'll tell about how we actually did the option 2 in the next slide. Second use cases is some of our services, the internal, this is not open source. Internal services, they cannot use either Kerberos or our internal custom authentication for various reasons. However, they happen to have the delegation token available. So in that case also, we use this delegation token-based authentication. So this is the actually high-level, very simple architectures. Read this right part service as a Presto, left part as like Apache Uzi or some other services. So this 3-step process, get the delegation token, that is also common. Number is step 2 and 3 are the new things we are suggesting. When you call to Presto, pass the delegation token as a header that you collected already. Then on the delegation token, we put authenticators on the service side, and they will validate the delegation token and the user identity. So this simple architecture actually was very much helpful for us. This is quick and easy with minimum development effort, which is being tested already for us. But there is another side effect is there. That is name node. Anything, as you know, actually whole Hadoop ecosystem, one of the Achilles heel is name node. As you know always, like this is our things. We want to keep it as sanitized as possible. We don't want to increase the load there and make it destabilize the core thing. If name node is down, whole thing is down. Everything is down. So we are very cautious, even maybe over cautious. So as we are increasing this extra load of number 3, line 3 is being added by new things that will increase the load. So we are actually working how can we reduce this impact by putting some level of caching in our authenticators. Having said that, I will transfer it to my colleague to run the rest of the work.
All right, thanks, Mohammed. Can you hear me? Okay. So Mohammed already talked about the first pillar, authentication. So I'm going to go over the next 3 pillars. So I start with authorization. So for authentication, it's all about verifying who you are. Are you really the one who you claim to be, right? Authorization, on the other hand, is about whether you have access or not for a particular piece of data. So I want to show the first the high-level architecture of the authorization part first. So in terms of authorization, there are 2 most important parties involved. First is data admin, the admin who owns a piece of data. Another is the end user who want to read or write the data. So on the admin part, so we build this self-serve platform for the data admin to manage their policy. And under the cover, all the policy is stored in a policy store. And more importantly, all these policies are being converted to extended echoes in HDFS. We'll cover more about this later. And on the user side, whether you read or write any data using any query engine, for example, Hive or Flink, whatever, eventually it will go to HDFS. And HDFS is where the enforcement happens. So this is actually a key design choice we made. So as Mohammed mentioned, we want the enforcement, all access to have the maximum coverage. And HDFS level, as the lowest level, can guarantee 100% coverage. So let's look at more details. How do we define policies? So in Uber, we also adopted the role-based access control, which is a widely used, very flexible, very powerful model to represent policies. However, as we mentioned earlier, we want enforcement to happen on the HDFS level. So how do we convert the policy to the echoes? So same diagram here. So at the mean of data, you define a policy, which is essentially a tuple of table, permission, whether it's read, write, and group, which group can have this permission. And we implement this policy propagator, which actually will look at the table. Table, what is table? It's essentially an abstract concept, right? And physically in HDFS, it's essentially a set of data directories. The propagator actually will look at table, find all the data directories, and set echoes on all the directories based on the policy. So in order to achieve this, we actually had two choices. So first choice is we can use HDFS plugins provided by either Sentry or Ranger on name node. So second option is what we implement at Uber using the propagator to set the echo directly. So why we choose option 2 instead of option 1? I want to bring up echo what Mohammed mentioned, name node. Name node is really a key component of HDFS ecosystem, and it's very, very sensitive to everything. And on the other hand, all these plugins, they need to, well, it provides lots of benefit, but it also needs to cache all the policies and the tables metadata in memory, which adds overhead. So in Uber, we consider the name node scalability and stability as a very, very big concern. We consider that very seriously. That's why the primary reason we choose option 2, we don't want to bring any overhead to name node. So we implement this propagator, which does the propagating the echo offline. So in practice, there are also some challenges in option 2. One of the biggest is how do you keep the policy and the echoes in sync? Because there are just so many different, so many edge cases where inconsistency can happen. So in reality, we have to build lots of monitoring and even reconciliation between these two to solve the problem. And it's actually an ongoing challenge for us as well. OK, that's authorization. So next part, I want to bring in a concept called partition-based access control, which is a relatively kind of new concept. So all the authorization or access control we talked earlier is targeting for table level. So, but in some cases, where we found partition-level access control is also useful. So for example, let's say as a data admin, you own a table, right? In some scenarios, you want define the policies such that you can control the access for historic data. So for example, you want by default everyone can only access new data. However, for a limited group, a restricted group, you give the access for all the data, all historic data. That's one of the use case. Another use case is maybe geography. So let's say as a data admin, you want to limit the data happening in a particular region to a restricted group. So the partition-level access, partition-based access control is targeting for these two scenarios. It's either time-based access control or geographic-based access control. So this is the example I gave earlier. Let's look at how this works. So same diagram here. Admin defines a policy. The three tables table privilege group is we talked about earlier. In this case, I want to emphasize the time restriction we added. So for each policy, we can add this extra field. So for example, the first policy, employees has the read access for this table. However, there's a time restriction of X days, which means employee can only access data that happens in the past X days. The second policy indicates a authorized group has no restriction. They can access any data. So under the cover, the same policy propagator will actually set different echoes for different partitions based on the policy we defined. So in the first partition this year, the new data, you can see the employee and the authorized group both have read access. However, for an older partition, like last year sometime, only the authorized group has the read permission on HDFS. One thing to note is when time goes by, new partition can become older according to the policy. So the policy propagator actually has to refresh the echo periodically based on the policy and based on time. Right, that's all about authorization. Let's go to the next pillar, auditing. Auditing, as we all know, is very, very important. This diagram shows the high-level diagram of how auditing works. The first part, or the most important part, is collection. We want to collect all type of data for auditing purpose. So there are a couple of types of data. One is HDFS, file level, access logs. Second level is query level, query engine level, like Hive or Presto, whatever. We collect the query level audit logs as well. Third one is service level, service audit logs. All these audit logs are pushed to Kafka in real time. Now, the second part. Once we have this data in Kafka, we can either use some real-time monitoring, like Flink engine, anything like that, to basically analyze the data in real time. For example, doing anomaly detection is one example. Or we can use any query engine to analyze data offline, since all the data in Kafka is also being pushed to HDFS. So we call this second part log analysis and monitoring. Okay, this is very high-level stuff for auditing. Last pillar, anonymization. So this is, as I mentioned, is a very overloaded term. In a high level, it's basically any mechanism to transform data into unidentified form. So there are lots of different technologies to achieve this. In this talk, I'm going to just focus on how we enforce the authorization, how we enforce access control using encryption. So one of the techniques. So why we need this? So imagine you have a table, right? Your own table, and it has tons of different columns. However, maybe in some scenarios, only a handful of these, are considered as sensitive. And among these sensitive columns, they can also define, they can have a different sensitive level. This is an example. The red ones are considered as sensitive, and they have different levels of sensitivity. So how do we do the access control based on the column? The change here is, as I mentioned, we want to do any enforcement in HDFS. However, HDFS doesn't understand what is column. It only understands the bias or blob. So our approach is we enforce this in the data format level, for example, in PACWI level. And for any sensitive columns, we encrypt it in PACWI before writing to HDFS. So we are now actually working with IBM and other companies through the PACWI community on this. So there are some reference. If you're interested, take a look. So I'm just to talk about high-level design of this. Basically, as a writer, this shows the writer path. As a writer, imagine you have two columns. C1 is considered as non-sensitive, and C2 is considered as sensitive. It's in the red font. So for C2, before we write to HDFS, we will encrypt it. There's a key management module involved as well. And on the reader part, before we return the data to the reader, we will check the user identity. Only if you have the permission to access column 2, we can get the key. Then we decrypt it, we return it back. If you don't have access, we will just return error or return your garbage data. That's kind of the high-level diagram of how we achieve column access control using encryption. Now I'm going to turn back to Mohammed to conclude this.
Thank you, Wei. Check the time, yeah. So this takeaway is a kind of like my self-reflection. It's nothing specific to this thing. Being a part of this Hadoop community for a little longer time than a lot of you, actually there is some self-realization happened to me due to this security feature. And I believe some of my friends are there who actually been there for time zero of the Hadoop world. So what happened at the beginning, our use case was all this internet audit log. People are coming there, try to put it there, how can we expand HDFS and other things. Our security thinking was mostly focused on that. But in the meantime, things actually change dramatically. Whether we like it or not, people start using Hadoop for any type of data. Salary data, personal data, employee data, every company has this thing. So this actually brings a new set of challenges for the Hadoop community itself. So the original thought that we think at the beginning is being challenged. Although we are the old timer, that's why actually it took longer time for us to realize this thing. As the new things are coming, all these GDPR, HIPAA, and other things are coming, and new set of requirements coming in general to everybody. So what I'm just thinking that I realize that there need to be different set of architecture and may need to be thought of. The more specific thing, I don't want to talk about that, but this is challenging the people, and we are trying to solve the problem in a patchy way. The different patch we are trying to put here and there to address this problem. But overall, I think this is one of the things, overall the trend in the market, we need to think differently. This is one of the case. If you'd have come to me 3 years back asking we need a row level, column level access control for any reason, I would try to shoot you down at the beginning. No, it's not Hadoop. Go for some other placement. Oracle might already have that, or they use something else. So those are the things that are there. But nowadays, I am now supporting the same thing. This is the things change in this community. So that is one of the things we need to think of, that how we have some approach, it's working, but in the longer term, will it work? So this is the challenge for all of us who is involved in different products in the Hadoop community. We have to think of ourselves. The last one is actually my experience in the last 1.5 years. From technologically, security should be considered at time zero. If you're thinking, okay, security is here, we'll do it later, forget about it, we'll just make the service available to the people, quickly make it available. In that case, actually, it becomes harder if you retrofit it later. And sometimes you may need to re-architect your infrastructure. And that is my another realization from this takeaway things. I believe I will open up for QA, but I want to call out one thing. I did not write it here. That is obvious. We are hiring, just to tell you. Obvious. OK. I think, yeah, we are open for a question, if you have any.
Can you use the mic there? Thanks.
You talked about implementing Kerberos in the cluster. I think there are a couple of ways to implement the Kerberos. So what are the challenges, or like what option was the best suited?
Yeah, so I got the question. Actually, the Kerberos implementation is challenging. He is asking, there are multiple ways we can do that. What are the ways we actually implemented? So we actually took a different approach, that in our company, actually, the central thing, they are actually asking not to use Kerberos, but Hadoop need to use Kerberos. So we decided to implement the Kerberos infrastructure only for Hadoop, primarily for Hadoop. So we have our own KDC infrastructures that our Hadoop team is managing, and we are using based on that. However, we have another thing called one-way trust, because we have Active Directory. Active Directory already has a built-in Kerberos there. So we use one-way trust with the Active Directory. That means if you take any Kerberos ticket from Active Directory and present it to Hadoop Kerberos, they will approve it. But it's not the other way. That's why it is called one-way trust. Did I answer your question? Thank you. Yes, please.
So when you're using encryption, did you use any vendor tools to encrypt your data, or was it in-house built?
Okay. So the answer is actually, this feature is actually, I would say, actually very active development phase. So we are trying to put at the code we are working on it. This is development phase. So we are trying to put any built-in, any pluggable encryption module there. We are considering some of like hardware level encryption support is there. Some Intel architecture is already supporting it. We are planning to use it there. At this point, to give you the answer, I do not have an exact answer. I'm giving peripheral answer because we did not deploy it in our production yet. So the overall plan is actually we'll put any custom default encryption algorithm there that fits our requirement based on our analyzing. This is development. That's why I cannot give you any concrete answer. But all options are open for us. Sorry for tangential answer.
No, that's okay, because we are also looking for encrypting the data at rest. Right now, we don't have a solution whether to go with vendor solutions or should we build a custom solution.
Very good. We can talk actually offline also on that.
Sure. Thank you.
Thank you. Okay. Yes.
So are you considering using the HDFS end-to-end transparent encryption, like to keep the data encrypted at rest?
Currently, we did not turn it on yet. This is in our consideration, like encryption at rest for all Hadoop data.
Yes, yes.
Currently, we are not doing it because we are concerned about the performance of that feature.
Okay. And one more question regarding the the column level restrictions that you're providing. Are you also providing, like, I mean, if the column is restricted for viewing, is it available for querying?
Yes, that's
because if I can give you a use case. Like, you wouldn't want somebody who's working on a data to look at the value of the column, but you would want them to work on a column value.
I see. So basically, I'm just thinking of one of the column has a restricted access. Yes. You don't have access. Yes. Can you do some filtering? Yes. Something like that, right? Yes. Probably that's the one. That is probably we'll at this time tell no, we will not support it. That's probably it's not being supported yet. Yes. Only use case as we are thinking, like there is a like predicate push down and other things on the format level that we may need to support that. We are still arguing that. The reason is if I give you like you select where clause or something, then actually we are giving you some information already.
Yeah,
so
but it's kind of a common thing. I mean, that comes to my mind that you would want to share the data, but you wouldn't want them to look at it. And you'd also want them to filter around some keywords. Yeah.
Yeah, that is actually the very, very good suggestion actually. We are actually talked about that. We did not implement anything. This is most of a tokenization. We are just thinking that we may not give you the exact age of a person, how many years old that person is, but we can give you tentative, like this person is 20 to 30 years old, that range. We'll not give, actually he is 28. So that is also another thing for business use cases like that can be helpful. But at this point for column level, we are not implementing that feature.
And I mean, my question, the first question towards transparent encryption was just, I was just wanting to see that anybody using that, or is there any performance hit? There is a definite performance hit on like when you access it without encryption, with encryption. So I just want to know if there's somebody who's done benchmarking on that.
Very good question, very good question. So at this point, as we are developing, we are evaluating it with our like IBM and other folks. I can give you some data point on that one, although it's not totally published by the IBM team also. So it depends on actually like how many columns we are encrypting. We find it out less than 1% of column will be encrypted. So the overhead will be minimal based on the what algorithm we use. The previous question is also like if we use Java 9 with Intel instructions for the encryption, built-in instruction, the impact is less than 1% overhead. But if you are using other than this, normal Java 8 and other things that does not have special things, it could be as high as 5 to 10% overhead could be there. But it is very early stage of the evaluation.
Okay. Thank you.
Thank you. Sorry.
Yeah, is the policy propagator that you showed on the slides an in-house tool or using something off the shelf?
Currently, I can talk from OA, and currently it is our in-house at least, and we have our own product internally. Just do the translation and continuously keep in sync from policy world to the ACLS world. It is a very basic thing. If you have time, we can talk. Implementing this thing is not going to be that hard one. We can talk to you more details on that. But at some point, we may actually open source that. Thank you, everybody. Yes.
Okay, thank you.